Hey everyone, welcome to my channel. So today's topic of discussion is how do airplane black boxes work? Imagine an airplane disappears from radar in the middle of the night, flying over the ocean. The world waits anxiously for answers. How do investigators figure out what went wrong when no one survives to tell the story? The answer often lies inside a small, almost indestructible device, the airplane's black box. Despite its name, the black box isn't black at all. It's painted bright orange so it can be spotted more easily after a crash. But it's more than just a box. It's the memory of the entire flight, recording crucial data and voices from inside the cockpit. Today, we are going to uncover the fascinating technology behind these devices and how they help make air travel one of the safest ways to travel. A black box actually consists of two main recorders. The first is the Flight Data Recorder, or FDR. This captures hundreds of flight parameters every second: altitude, airspeed, engine thrust, fuel levels, wing positions, even the angle of the radar and the elevators. Think of it as a digital logbook that writes down every move the airplane makes. The second is the Cockpit Voice Recorder, or CVR. This records everything the pilots say and hear: their conversations, instructions from air traffic control, cockpit alarms, and even background noises that can hint at mechanical issues. Together, these two devices provide investigators with a detailed timeline of what happened in the moments leading up to an accident. Here's an interesting twist: the black box is almost always orange. Early versions were painted black, but after several crashes, investigators realized they were too hard to find in wreckage. Now they are bright orange with reflective tape to make them easier to spot in rough terrain or underwater. So, why still call it a black box? Some say the term comes from the early days of electronics, where mysterious and complex devices were nicknamed black boxes because their inner workings were hidden. The name stuck even though the color didn't. Inside the black box lies some of the most resilient technology ever created. Modern recorders use solid state memory chips, which are far more reliable than the old magnetic tape. These chips can store up to 25 hours of cockpit voice recordings and hundreds of hours of flight data. To protect this information, the memory unit is enclosed in multiple layers: an aluminum housing, high temperature insulation, and a stainless steel or titanium shell. Thanks to this design, black boxes can survive impacts of over 3,400 times the force of gravity, fires reaching 1100 degrees Celsius for a full hour, and being submerged in ocean depths up to 6,000 meters. Every black box also has an underwater locator beacon, often called a pinger. If if it ends up in water, it automatically sends out an acoustic signal once per second, which can last for about 30 days. Search teams use this signal to track it down. In short, the black box is designed to be one thing that survives when everything else is destroyed. When a crash occurs, one of the first missions is to find the black boxes. Search crews deploy sonar equipment to detect the pinger signals. Once located, recovery teams often work in extreme conditions, sometimes on mountain sides, sometimes at the bottom of the ocean. After retrieval, the recorders are sent to the specialized laboratories. Extracting the data isn't as simple as plugging in a cable. Engineers use highly secure and specialized equipment to carefully download the recordings, making sure nothing gets damaged or corrupted. Once the information is decoded, investigators reconstruct the flight second by second, piecing together the chain of events that led to the accident. The black box has been at the center of some of the most important aviation investigations. Take Air France Flight 447 in 2009. The plane crashed into the Atlantic Ocean. It took nearly 2 years to locate the black boxes, which were resting 4,000 meters below the surface. When they were finally recovered, the recordings revealed that icing on the plane's sensors led to the autopilot disconnection and confusion in the cockpit, ultimately causing the crash. On the other hand, Malaysia Airlines flight MH370 in 2014 is a haunting reminder of the limits of current technology. The black boxes were never found, leaving many questions unanswered. This tragedy sparked a global debate about updating the black box technology to prevent such mysteries in the future. Because of insights gained from black boxes, aviation authorities constantly improve training, cockpit procedures, and aircraft designs. In many ways, every lesson learned from these devices makes flying safer for all of us. While black boxes are essential, their limitations are clear. If they can't be found, valuable information is lost. That's why new solutions are being explored. One idea is real time data streaming, where critical flight information is continuously transmitted to the ground stations, ensuring it can never be lost. Another innovation is deployable recorders, devices that eject from the aircraft during a crash and float on water, making them much easier to recover. These advancements could mean that in the future, no flight data will ever go missing again. So, the next time you step into an airplane, remember that there is a small device on board built to survive fire, crushing forces, and the deep ocean. Also, it can tell the story if something goes wrong. The black box is a silent witness, one that has shaped aviation safety for decades and continues to push the boundaries of technology. Would you trust live streamed flight data over traditional black boxes, or do you think both are necessary? Share your thoughts in the comments. If you enjoyed this video, don't forget to like and subscribe for more deep dives into the technology that keeps our world moving. See you in the next one.